Hello, we are going to be discussing section 5.6, graphing linear inequalities in two variables. Excuse me. So our objective is going to be to check solutions of linear inequalities. We're going to graph them and then use that graph to solve some real life applications. So before we dive into what a linear inequality is, let's jump way back to chapter 3 where we talked about a linear equation in two variables. So way back in 3.2, a linear equation in two variables has two variables, usually an x and a y, and an equal sign. And then normally you add or subtract them. You could have some multiplying and dividing. There's a linear equality. There's a linear equation. Okay, today what we're going to be changing up is the equal sign. Instead of an equal sign, we're going to be using inequality signs. Our inequality signs are the less than, the greater than, the less than or equal to, and the greater than or equal to. Okay, so basically all we're changing is we've been dealing with all of these equations. For example, 2x plus 3y equals 5. What we're going to do is we're going to come in, we're going to get rid of that equal sign, and we're going to make it a greater than instead. So now we're not necessarily looking at where is it equal to 5, we're looking at where is it bigger than 5. Okay, so what this does is instead of having like one single ordered pair as a solution, you're going to have a lot of different ordered pairs of solutions, a lot of different points. Okay, so a solution of a linear inequality is still the same thing. It's an ordered pair. It's still an ordered pair because you still have an x and a y. The two variables are normally an x and a y. So it's still an ordered pair that makes it true. So we're still looking for that ordered pair that makes it true. So to tell whether an ordered pair is a solution, what we do is we sub in. So I'm going to sub in this 1 for my x, sub in this 9 for my y, and we're going to write that out. So I have 2 times 1 plus 9. Is that less than negative 3? And I'm going to question mark by it because I don't know if it's less than negative 3. So we'll go ahead and work it. So we have 2 times 1, which is 2 plus 9. Which is 11. Is 11 less than negative 3? No, so we put a slash through the less than, and we would say no. It is not a solution. We end up getting a false statement. Okay, now this next one again, same idea. We're going to put the 2 in for the x. Minus 3, there's a times there, times y, which is negative 2. Is that in fact greater than or equal to 8? Question mark. Well, we have to do the multiply first, so we're going to do that multiply there. Negative, and I'm going to rewrite this as plus a negative. So 2 plus negative 3 times negative 2 is positive 6. 2 plus 6 is 8. Is that greater than or equal to 8? Well, it's not greater than, but it is equal to, so it works. Yes, that is a solution because it worked. Okay. Right, so now the graph of a linear inequality is really just a picture, okay? It's a picture that shows all possible solutions. And it's gonna be a little bit different from the linear equalities. In the linear equalities, the graph of them was just one nice little straight line, okay, because we had that equal. Okay, now we're going to be looking at greater than or less than. So what that's going to do is, this is section 3.2, is we're going to look at, we're either going to look at the numbers up here, all the points up here will work, or all the points down here will work. Okay, so it's going to be more than just the line. The line is going to divide it into two halves, divides our plane into two half planes is what we call it, And one of these half planes is going to work. We need to figure out which one. Okay, so to do that, okay, to find it, so what our solution, I'm just going to graph I'm just going to graph a random solution over here. I'm just going to graph a random line. So just graph a random line. So instead of looking at just the points that are on that line, we're going to be looking at the points on either one side or the other. So it's going to involve some shading. Okay, because that means, so that would mean like all the points, all the ordered pairs over here will work. Okay, so let's work through the process on how to do this. Okay, we've got 3 steps. First, we have to graph the line. Okay, so step 1, what we do is we're going to graph what we call the boundary line. Okay, we're going to graph that boundary line, or just the straight up, what if it was a y equals, how would we graph it? So we're going to graph the boundary line. If it's a strictly less than or greater than, we need to graph it dotted, because that means we don't include like on the line, we just go all the way up to it. If it's equal to, then we would do it solid line. Okay, so let's go ahead and let's do this first one. We want to graph y is less than or equal to 2 in a coordinate plane. So first I need to graph the boundary line. So I'm going to graph this line, y equals 2. So to graph that, first thing I need is I need my axes. So I'm going to draw my axis in black. So let's do my vertical one and my horizontal one. Okay, so this one needs to cross the y-axis at 2. So cross the y-axis at 2, which is right there. So it's going to be this straight horizontal. So there's my boundary line there in blue. That's what we call our boundary line. Now, if you notice, this is a greater than or equal to, so that tells me that line needs to be solid. Okay, I don't draw any dashes through it, not a dotted or dashed line. Okay, so I should say dotted. A lot of times we say dotted or dashed, depending on how we write it. We normally do ours dashed because that's easier to draw. That's a D. Okay, all right, so now that we've got our boundary line graphed, step 2, I'm going to do in green, test a point. Test a point on one side. So I need to know which side of this line do I have to shade. Am I going to shade these points up here above that blue line, or do I need to shade the points down here below the blue line? So I need to pick a point on one side. Doesn't matter what side, pick a point. I like to pick the easiest point, which are normally the zeros, so I'm going to pick the point 0, 0. So the point I'm going to test, my testing point is the point 0, 0. And I'm going to plug that into here to see if it works. Okay, so I'm going to plug it into there. So I'm going to check my y. My y is 0. Is 0 less than or equal to 2? Yes, it is. It worked. Okay, so that leads me to the step 3. That's the shading part. Shade in the side with the point if it worked. And the other side if it didn't. And I would really encourage you, when you're shading, don't shade it in solid. Just because if you mess up and you have to erase, that's a lot of work. Well, my point 0, 0 worked. So that tells me that I need to shade on that side of that blue line. So I'm going to shade down here. So that tells me that any point down here will work. Meaning if I picked this point over here, I don't know, the point 4, negative 4. That point would work. This point over here will work. This point over here will work. Any of these points in this blue section, this red shaded section will work. Okay. All right, so let's go ahead and let's do one a little more complicated. Okay, so we're going to graph negative x plus 2y is greater than 2. Okay, this one, graphing that boundary line is going to take a little work, because the easiest way to graph is if it looks like this, y equals mx plus b. So I need to get it to look like that first. So to graph my boundary line, I'm going to go ahead and I'm going to change this to an equality to graph it. I'm going to have to add x to both sides. that's 0. 2y equals positive x plus 2. Divide by 2. Y equals, there's a 1 there, 1/2 x plus 1. So I'm going to graph that boundary line. So let's put my x's in. Okay, this needs a y-intercept of 1. There's my y-intercept. That's why we spent all that time graphing. Y-intercept of 1. A slope of 1 over 2. So 1 is my rise, 2 is my run. Rise of 1, run of 2. So there's my line. Okay. Now we look. This is a strictly less than, so I need to dash it. I like to just come through with my eraser and just kind of spot erase to make it dashed. So there's my dashed line. Okay, and then now I need to pick a point. So let's pick a point, I don't know, on either side. Again here, I'm going to pick the point 0, 0. That's always the nicest point to pick, and put it back up into the original before you did any messing around. So we've got negative 0 plus 2 times 0. Is that greater than 2? 2 times 0 is, so negative 0 plus 0. Negative 0 plus 0, 0 greater than 2. Nope, it didn't work. So I need to shade in the opposite direction. That green point didn't work. So I'm not going to shade down here because that one did not work. So that tells me I need to shade up here. So that means any point I pick up here, this point will work, this one will work, this one will work, and it'll go on for forever. I can pick points wherever. Those will work. Okay. All right, our very last problem, a word problem. Okay, example 4. You can spend at most $10 on grapes and apples for the fruit salad. So I can spend at most $10 on grapes and apples. So the money I spend, money on grapes plus the money on apples, can't be more than $10. So that means it has to be less than $10 or equal to. I can spend up to 10 bucks. So the money for grapes plus the money for apples has to be less than 10 bucks. Okay. Next, grapes cost $2.50 per pound and apples cost $1 per pound. Okay. So my grapes are $2.50 times the number of pounds of grapes. That's the pound symbol, plus $1 times pounds of apples. Write and graph an inequality that represents the amount of grapes. So $2.50 times grapes. So 2.5 times grapes plus $1 times apples. And we can use two different variables. Has to be less than or equal to 10. Okay, so I'm going to now come in and I want these to be an x and y. So I'm going to have my grapes be my x, my apples be my y. So grapes are x, apples are y. And it says to write and graph an inequality. Well, there's our inequality. We've got it. Now we need to graph it. Well, I'm thinking we're only going to be dealing with positive numbers of apples and grapes. But maybe we better double check. I'm going to wait until I get this into y equals mx plus b form. We want it to look like this. Y equals mx plus b. So we've got 2.5x plus y is less than or equal to 10. So I'm going to have to subtract the 2.5x from both sides. Y is less than or equal to negative 2.5x plus 10. Yep, my y-intercept is 10. So I'm thinking first quadrant's good on this one. Axis that way. Axis that way. Okay, we're going to graph the line. Y-intercept is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, what about the slope? Okay, I could get 2.5 as a fraction, which 2.5 as a fraction, 1, 2, 3, 4, 5 halves. So I need to go down 5 over 2, down 1, 2, 3, 4, 5. Okay. Draw that line in. It is an equal, so it can be solid. And then we need to test a point. So let's go ahead. Let's pick a point over here. I guess we could pick 0, 0 again. As long as 0, 0 is not on the line, go for it. So we're going to test the point 0, 0 back in our original. So 2.5 times 0 plus 0, is that less than or equal to 10? So we get 0 plus 0 less than or equal to 10. No. So I need to shade over here. And then it says, identify and interpret 2 solutions of the inequality. Okay, well, basically, I just need to pick a point over here that makes sense. And wait, did I goof? Yep, I did. Anybody catch it? I shaded the wrong way. Is 0 less than or equal to 10? Yes, it is. This should be yes. So I need to shade this direction. And it doesn't make sense to shade the negatives because I can't have a negative number of apples. Okay, so now it says to identify and interpret 2 solutions. So I just want to find 2 points over here. So here, this point right here, it's over 1, up 1. So I could buy 1 pound of grapes, 1 pound of apples. Okay, so I have the order pair 1, 1, which means I could buy 1 pound of grapes, and 1 pound of apples. There's a solution. It says 2 solutions. So here, what about this one here? I could do 1 pound of grapes and 1, 2, 3, 4, 5 pounds of apples. So I could go 1 pound of grapes and 5 pounds of apples. There's another solution. I could list solutions for forever. I could even buy partial pound. I could buy half a pound of grapes and so many pounds of apples. As long as the point is over here or on this line, it will work. Okay. All right, now for your practice, I want you to go to page 271. Do 4 through 38 even, 46 through 80. Once you have them done, submit them, and I will get you the answer key.